G'day chemistry students, in this video we are looking at dot point 7.1.1, 7.4.1 and 7.5.1. This is the final video in our naming organic compounds series. In particular, we are looking at primary, secondary and tertiary alcohols, amines and amides. There's some concepts here which are going to be really important for the remainder of the module, as well as a couple of additional naming rules. Let's get into it. So to begin with, we're going to be looking at primary, secondary, and tertiary alcohols. And I'm just going to acknowledge that we can use the notation shown up here in the title, as well as on these labels to denote primary, secondary, and tertiary organic species. So when we're trying to determine whether or not an alcohol is primary, secondary, or tertiary, we look at the carbon that is attached to the hydroxyl group and figure out how many carbons it is bonded to. So that could either be one carbon, two carbons, or all three carbons for the remaining three bonds. And that is directly related to its name. One carbon attached is a primary alcohol, two carbons attached is a secondary alcohol, and three carbons attached is a tertiary alcohol. Now we can't have a quaternary alcohol or one that has like a 4 in a little circle, because if that was the case, then there would be 4 carbons bonded to the carbon attached to the hydroxyl group. And for that to occur, either the hydroxyl group wouldn't exist, or there would be 5 bonds onto the carbon, and that we know does not work when drawing organic structures. The carbon can only hold 4 covalent bonds. So in our first example here, ethanol is a primary alcohol. We have our 2 carbons, and for this carbon on the end, there's an OH, there's a hydroxyl group. The remaining 2 bonds on the carbon are then hydrogen. For propan-2-ol, it's a secondary carbon, so 3 carbons. The carbon in the middle is attached to carbon 1 and 3. Its final bond is a hydrogen. And for the tertiary alcohol, our example here is 2-methyl-propan-2-ol. So the only difference between these two is the hydrogen versus the methyl group here. And in this scenario, the carbon is attached to the hydroxyl group and all remaining bonds are carbons. There are some similarities when looking at primary, secondary, and tertiary amines. The biggest difference is we're not looking at how many carbons are bonded to the carbon attached to the functional group, but rather the number of carbons which are bonded to the nitrogen itself. If nitrogen is only bonded to 1 carbon here, then that is a primary amine, so carbon and NH2. So here the nitrogen uses one of its bonds to bond to carbon and the other 2 for hydrogen. For a secondary amine though, the nitrogen is only bonded to 1 hydrogen. The other 2 bonds are bonds to carbon. So in other words, this nitrogen would be a part of a carbon chain. And for a tertiary amine, there is a nitrogen that is only bonded to carbon. So technically, the functional group of an amine can change slightly as well. We're more concerned about the existence of nitrogen when looking at the functional group, rather than it just being NH2 itself. Technically, the nitrogen functional group can be NH2, NH, or just N, depending on whether or not the amine is primary, secondary, or tertiary. This has an impact on how we name amines. Naming a primary amine is quite straightforward and simple. We just identify the position of the NH2 group on the carbon chain itself. Once we move to a secondary amine though, there's a few steps that we need to follow. First, we need to identify the main chain, and that's going to be the longest chain attached to the nitrogen. So in this first example here, we have 2 carbon chains attached to nitrogen in the center. There's a chain of 2 and there's a chain of 1. So this would be the longest chain here. That is going to be the name of our main chain. The second step that we need to do is look at the alkyl branch, the chain of shorter length, and identify that and figure out how many carbons are on there. We then use N- notation instead of a number to identify the position of the alkyl branch. And when we use N-, we're not saying that it's on a numbered carbon, but rather it is attached to the nitrogen, the amine group itself. So usually when we put a number in front of an alkyl group, it's to say, hey, it's on one of the carbons on the main chain. Because this is not a carbon and a nitrogen instead, we use an N to denote its position. So in this example, the main chain is our F, so ethane amine, because we still identify that we're working with an amine group, so it's an ethane amine. Then we label the alkyl chain that is here and label that as N-methyl at the beginning of our chemical name. In our second example, we have two chains, 1 and 2. This has 2 carbons and this has 3. This makes the right-hand side our main chain. So this is a propane amine and the alkyl group is N-ethyl. So put that together, N-ethyl propane amine. I'll come back to this one in a second. In this example here, we have a chain of 2 and a chain of 1, 2, 3. So again, the propane chain is the longest. So we have a propane amine and we label the alkyl chain as an N-ethyl. Now the difference between N-ethyl propane 1 amine and N-ethane propane 2 amine is the position of the amine on the main chain. Here, if this is the main chain, this is the first carbon and that's what's attached to the nitrogen. However, on the propane 2 amine, the amine group is attached to the second carbon. So this is why we have this instruction up in step number 1, number the position of the amine on the chain if necessary. So if there are multiple locations where the amine can come off the main chain, then that still needs to be labeled as we did for primary amines. When looking at tertiary amines, we follow a very similar set of rules. There are a couple of additional rules to make as well. So the first thing that we still need to do, select the main chain as the longest chain and number the position of the amine if that's required. We then identify the length of the other 2 alkyl branches. So in this case, there's going to be 2 alkyl branches that we need to name. In this example here, we just need to use steps 1 and 2. We look for our amine group and then the branches that come off it. So we have 2 carbons, 1 carbon, and 3 carbons. The longest and the main chain is this one that has 3 carbons. So it's going to be a propane amine. Notice that we name it as propane 1 amine because the nitrogen is bonded to one of the end carbons. We can then name our other 2 branches. We have an ethyl branch and a methyl branch. We use our N notation to identify their position. They're both attached to the nitrogen. And because the 2 branches are of different lengths, we name them in alphabetical order. So N-ethyl and methyl propane 1 amine. Similarly, in this example, our main chain has 3 carbons. It's a propane amine again, but in this case, it's propane 2 amine because the nitrogen is attached to the second carbon on the main chain. We then have an ethyl group and a methyl group again. So we're going to label that N-ethyl and methyl. Again, we're following our alphabetical order. In our final example, what we have is, again, a tertiary amine. The longest chain is a chain of 2. That is going to mean that it's labeled as ethane amine. For the other 2 branches, we just have methyl groups. So using similar conventions that we have done before, we're going to label both of those ethyl groups as N and N, separated by a comma, and then identify that because there are 2 methyl groups, we're going to call it dimethyl, using that same numbering system that we've used previously as well, meaning that this compound is NN dimethyl ethane amine. Similarly to amides, we look at the number of carbons attached to our nitrogen. So a primary amide is what we've seen already. They exist at the end of a carbon chain. So this would be the final carbon in the chain. It's got a carbonyl group and an NH2. If the amide is in the middle of a carbon chain though, there will be 2 carbons that the nitrogen is bonded to. And then this final bond here would be a hydrogen. However, if there is an additional alkyl branch, it becomes a tertiary amide. Therefore, we have connection to 3 different carbons. When we're naming a secondary amine, we still continue to use a lot of the naming rules that we've used already. The biggest difference between naming an amide and an amine, and I've just noticed that that's a typo, apologies, but when we're naming an amide, we always select the main chain as the one that has the carbonyl group. So whether or not it's the long chain or the short chain, the chain with the carbonyl group in it is known as the main chain. We can then identify the other alkyl branch and then just use N notation to identify that it is attached to the nitrogen. So for example, this chemical here has a chain of 3 and a chain of 2. Even though this is the longest chain, it is considered the alkyl chain because it does not have the carbonyl group on it. So this is an ethane amide, and because it's a secondary amide, we also have to identify what the chain is, and that's an N-propyl chain. Putting all that together, we end up with N-propyl ethane amide. In this example, I've just flipped the two chains. So the main chain now has 3 carbons in it, and the alkyl branch has 2 carbons in it. So this is an ethyl propane amide. And in the final example that I have prepared, we've got a main chain with 3 carbons and an alkyl branch with 5 carbons. So this is N-pentyl propane amide. So adopting all of the rules that we've used so far, we can then apply some of those to be able to name our tertiary amides. Again, typo, apologies. Our main chain has 3 carbons in it, and we have a methyl and ethyl branch. We're going to be ordering those alphabetically, so N-ethyl and methyl propane amide. In our second example, we have a main chain of 3, so it's another propane amide, and we have a branch with 1, 2, 3 carbons, and 1, 2, 3, 4, 5 carbons. So a propyl and a pentyl. Pentyl comes first because of alphabetical order, so N-pentyl, N-propyl, propane amide. And for our final one, we have a main chain of only 1 carbon and 2 propyl branches. So here we say that both of those propyl branches are attached to N, so NN, dipropyl, and methane amide because there is only 1 carbon in the main chain. Thank you very much, everyone. In the next video, we're going to be covering a topic which is called isomers. This concept will help us to think about the structures of organic chemicals and their molecular formulas. But until then, have a good one.